Okay, thank you very much. Good morning, everyone. I'm Lawrence Poon. Thanks for the introduction by our MC. I'm currently serving the ASTRI. The full name of ASTRI is Applied Science and Technology Research Institute. That is the largest 100% financed by the government research institute in Hong Kong, right? We have around 600-something people right there. Now today, my topic is quite interesting because in Hong Kong, we're glad to have a very strong support from the local government. We've deployed quite a lot fully autonomous vehicles projects in Hong Kong, right? So today, I would like to share with you the application and challenge of autonomous vehicles. First of all, let's spend 1.5 minutes to have a short video for the introduction of our ASTRI.
Hong Kong is moving towards a new era of smart mobility. Connected vehicles are changing the landscape of transport technology, enhancing the day-to-day safety on our roads and traffic efficiency by bringing vehicles, pedestrians and infrastructure together. This is connected vehicle technology, made in Hong Kong, with low latency, reliability, a seamless connection. ASTRI introduces cellular vehicle-to-everything CV2X technology, leveraging next-generation technology. 5G plus CV2X will enable the brand-new future smart mobility infrastructure. Vehicles will be able to communicate with each other, receive dynamic or static infrastructure information, and detect road threats through sensor technologies. ASTRI is the pioneer in connected vehicle technology development in Hong Kong. With the support of the Innovation and Technology Commission and the Transport Department, ASTRI introduces one of the largest CV2X public road tests in the world on 14 kilometers of open roads from the Hong Kong Science Park to Sha Tin Town Centre, where CV2X devices are installed along the route. The ASTRI research team works day and night with our partners to build and deploy CV2X for the first ever public road test in Hong Kong.
Front left pedestrian alarm. Roundabout vehicle incoming. Do not enter. Front collision warning. Front collision warning. Left blind spot vehicle coming. Left blind spot vehicle coming. Speed limit 50. Speed limit 50. Congestion ahead, please take right alternative route. Intersection alarm, front right vehicle coming. Found abnormal vehicle. Found abnormal vehicle. Found abnormal vehicle. Road work on the road ahead, please drive carefully.
ASTRI is committed to contributing to smart mobility in Hong Kong. We will continue to research and innovate and bring lasting technological impact to our city. ASTRI.
All right. In fact, I can finish my speech right now because the video is just too informative, right? Okay, it seems that from the video, it repeatedly emphasized the term CV2X, right? So what's the term CV2X? C is a cellular space. That means based on the 4G, 5G network, and the V2X is a vehicle to infrastructure. That means a vehicle can directly connect to everything, all right, around the vehicle, including the road infrastructure, just like the lampposts, the traffic light signal system, or even the buildings, or with the other vehicles, or with the passengers, or with the pedestrian around it, right? So, in fact, the success of autonomous vehicle relies on not only the vehicle itself, but the electronic subsystems installed on it, and also the electronic infrastructure installed along the highways, right? So today we are having the Global Resource Expo right here. Maybe some of the suppliers right here we will find it's quite strange. How come we have the speech today to talk about the autonomous driving application? It's simply because the one very simple message I want to let you all know that will be the future. No matter you like it or not. That means the future is everything related to automotive. They are related to electronics or the sensing technology or the connectivity between vehicle to the infrastructure. So pay more attention on it. That means in the future, there will be money, okay, to be generated from that industry. So whenever we talk about autonomous vehicle, in fact, we're talking about a robot, or be more specific, there should be a robotic vehicle. The term robotic vehicle can be divided into two major parts. First part is over 99% of the autonomous vehicle, they are pure electric vehicle. And the second part is on top of the pure electric chassis, all right? We retrofit the EV into a autonomous robot. That means by using the so-called X-by-wire technology. The so-called X-by-wire technology, that means steer by wire, drive by wire, brake by wire. That means all the various mechanical parts will be converted into the electronic subsystems, right? Again, if you're doing the business to produce or to design this kind of electronic stuff, well, that will be the big market right there. Now, in the past, we just used the very generic or layman term that is the driverless technology. In the future, please remember this new wording. We call it mobot or robotic technology. That means a mobility robot, just like a robot, right? Well, it's just some of the history. In fact, in Hong Kong, starting from 5-6 years ago, we start the trial of different type of autonomous technology. However, almost all those trial programs, they were implemented or conducted within a restricted area, normally within the university campus or within some residential area. That means without interacting with public road. Without interacting with the public road. That means over the past 6 years, there's no one single autonomous vehicle implemented in Hong Kong. They're running or they try to operate along the highways. No one. I'm not going to introduce too much about the so-called SAE autonomous standard level 1, 2, 3, 4. But anyway, as what I said, so far, we lack of data related to the real traffic operation for autonomous vehicle. That's why over the years, the major reason behind it is very difficult for Hong Kong to find the appropriate test sites and trial sites. Now, there are two different kind of stuff. So-called trial test site is we need a very standard proving ground to test the performance of the vehicle. Not only the drivetrain, but also the autonomous systems. And also the trial site is we need a cooperation with the industry and also the government departments so that we can select a open area, we can select a public road for the trial of our autonomous system. So we do not have the privilege to have the test site and trial sites easily found in Hong Kong. Because of that, lack of real traffic data, okay, from the public road. And that's why it's relatively difficult for the local government to finalize a so-called robust regulation for the operation of autonomous vehicle in Hong Kong. But don't worry, all these kind of problems will be solved shortly. Because we just start this big project. All right, that's my project. I just got some money from the Transportation Department in Hong Kong. We will deploy the fully autonomous shuttle bus in the West Kowloon Cultural District area. That will be a shuttle bus service, right? It's a round trip. There's just around 2 kilometer length for this route. that will be a 16-seat, 16-seat minibus, pure electric, and we will firstly deploy the wireless charging, okay, to facilitate the daily operation of the vehicle. That means, because I'm pretty sure for all other cities or for all other very similar projects implemented in Hong Kong in the past, they just use plug-in EV charging. It seems it's quite, I don't want to use the term, not that clever, not that clever, because if the vehicle itself can run autonomously, however, at the end of the day, we still need to use the plug-in EV charging. So we'll implement wireless charging to facilitate the operation of it. Wow. Normally, we use the term stand-alone autonomous technology. That means we rely on high-definition camera, a laser radar, or millimeter wave radar, many electronics sensors. On top of that, we still need to enrich or to enhance the infrastructure by building, well, you see, in this wood, I've identified 3 major points to build the so-called RS2, roadside unit. It's a kind of the other sensors, electronic sensing technology along the highway to facilitate operation of the vehicles. Wow. Now, all these are the electronic products to be retrofit on the pure electric vehicle. We need to equip at least 5 laser radar, very expensive stuff. Well, at least 9 very high definition cameras, 2 millimeter wave radars, 1 the GNSS, that means the GPS system, okay, the navigation system. And because the vehicle will also run under some area with coverage, and that's why with very weak GPS signal or satellite signal, we still need to use the other technology to facilitate the operation of the vehicle inside the tunnel, right? So we will also deploy odometer sensors and also the IMU, right? And also the high-speed 5G network. This is just a basic specification of it. That will be 16 seats, as what I mentioned before. And the top speed of this autonomous bus will be 60 km per hour. That is the highest, okay, highest in the market, the highest performance in the market. Well, whenever we talk about the deployment of autonomous vehicle, as I mentioned in the first 2 slides, it's very difficult for us to find the appropriate testing ground, the proving ground, and that's why in this project we will leverage the facility in mainland China. All right, because they're big enough, they're well equipped with the proving ground, and that's why we can realize the simulated traffic scenarios in the proving ground. For different road sections or junctions, just like the roundabout. And also, we'll test the wireless charging in that laboratories, and also the shield area, the shield tunnel, right? Shield tunnel, because in those specific operating scenarios, there's no 5G signal coverage. There's no satellite signal. That means the vehicle will not be able to operate with the assistance of the 5G and also the GNSS, that means GPS sensors. Right? Again, today I really understand that quite a lot suppliers on site, they're doing business. All right, they're trying to do business in Hong Kong or through Hong Kong to enhance their business or sales channel, okay? So it's a very good news is our ASTRI, okay, Applied Science and Technology Research R&D Center, we set up a sort of STMA, the Smart Transportation and Mobility, Smart Mobility Technology Alliance, okay? We welcome not only the government departments and also the user, but also suppliers to join us. It's free of charge, right? To join us. Currently, we have already attracted over 100 members to join our alliance. Now, the good stuff is just like the project that I just introduced, that is about the autonomous shuttle bus service in Hong Kong. Now, because of the SMTA successfully launched in Hong Kong in early of this year, for me, I can easily find the appropriate technical partner to work with us as a supplier of all those, say, the high-definition camera or millimeter radar or the a LiDAR, that means a laser radar. So it's very easy for us to form a full team to do the business. Now, in the alliance, all right, we have the participants from the government departments, from local research institutions, we have suppliers, that means from the local industry. Wow. So that is the overall, there's a total ecosystem, right? That means from the user side and the supply side. All right. So maybe I should stop on my presentation right here. So again, I would like to encourage all the local or overseas suppliers, if you really want to further enhance your sales channel or to have a better business to promote or to sell your electronics products, please try to understand more, to try to explore the business opportunity in the smart mobility business sector, in particular for the application of autonomous vehicle. Because as what I emphasized again and again is, the so-called autonomous vehicle combining two major stuff. One is the EV, electric vehicle. Electric vehicle itself is already including a lot of electrical and electronics products. And the second part is the so-called AV, autonomous vehicle systems, including a lot of sensors, camera, and also the very high performance computational subsystems right there. So please pay more attention in these two major sectors. Okay, that's the end of my speech today. Thank you very much. Thank you.